Hi again, everyone. So now that we have an idea of what Polya's problem-solving principles are and why they're important, let's go through each principle one at a time and break them down and talk about what it is and how to use it, and also how we can encourage our students to use each principle in the classroom. So let's get started. So if you remember all the way back to our very first video, where we saw our mnemonic device that my brilliant 8-year-old daughter came up with, I just wanted to get it back fresh in your brains because I'm going to be referring to it a lot throughout this video. Unicorns paint energetic rainbows, and here's a little visual that maybe if we visualize it, it can help us remember it even better. So just to jog your memory, a mnemonic device is a sentence or phrase where each letter stands for the letter of something we're trying to remember. And so here we're trying to remember each of Polya's principles of understand, plan, execute, and reflect. So just keep that in the forefront of your mind as we go through this video. Okay, friends, let's jump in and get started. We notice right off the bat our cute little unicorn right here, and that's sort of cueing us to remember that mnemonic device, unicorns paint energetic rainbows. And what is that U standing for? It's of course standing for understand, because Polya's first principle tells us that we need to understand the problem. And you'll notice I've put a little star here, and that's because understanding the problem is one of the most critical principles that Polya gave us. What tends to happen a lot with young students, and even with adults, I know I do this too, is sometimes we'll read a problem and jump right in and just start solving it without stopping to think about what am I actually being asked to do here. Young students especially, they'll read a problem, they'll see some numbers, and they'll just start applying operations they know, whether they're the right operations or not. And so how do we get our students to slow down, take a breath, and actually think about, well, what am I being asked to do here? Actually understand the problem. And it's all about taking a minute to reflect and ask ourselves some questions. So we can teach our students this process of asking these prompting questions to make sure we really have a good handle on what we're being asked to do. First, do I understand all the words being used? Because if I don't understand all the words, how can I possibly attempt to solve it? What am I being asked to find or show? This is critical, right? So I'm going to be given a whole scenario here, and it's my job to figure out, well, what's the question here? What's the problem here? What do I actually have to do? And so if students are struggling with that, something you can do to help them is have them restate the problem in their own words, or thinking through, is there yet another way to state the problem? And as they go back and start internalizing it and thinking through the words and how it makes sense to them, then they start to understand it and apply their own prior knowledge. And when they put it in their own words, that's a really powerful way of helping them to understand what's happening. This one's also really important. Is there extraneous information, and does that matter? And that goes back to making sure they understand what they're being asked to find or show, because they're going to be given a whole context, and they're going to need to be able to understand, oh, if this is what I'm being asked to show, I don't need that piece of information to actually answer this question. And so they can start to go through and pick and choose what they need and what they don't need. And what do you really need to know to find a solution? So which pieces of information do I need? And then which strategies do I have in my toolbox that I can use to attack this type of problem? And so once we understand the problem, then we're ready to move into the next step. Okay, so I'm seeing my paint on here, going back to my mnemonic, unicorns paint energetic rainbows. That P, right, for paint is helping us to remember the word plan. Polya's second principle is to devise a plan. And what do I mean by that? All I mean is pick a strategy. It's really time for us to brainstorm. What tools do I have in my toolbox that I can use to solve this problem? So I need to carefully consider the problem and think of a possible approach for finding a solution. So how do I do that? I need to be aware of the different problem-solving strategies and choose one to make a start on the problem. Maybe I have all these tools in my toolbox, like drawing a picture or making a table or guessing and checking or using algebra. I need to figure out which plan, which strategy do I want to pick to start this problem. And as experience is gained, choosing an appropriate strategy becomes much more easier. Like with anything else, I'm going to start to notice patterns of which type of problems are appropriate for which type of strategies. And we're going to talk a lot more about that in the next step. So once I've picked my plan, I've picked my strategy, I'm ready to get started and move into my third principle. Okay, on to Polya's third principle. I see my little lightning bolt of energy here, which is making me think of my energetic rainbows, right? What does that E stand for? It stands for execute the plan. This is Polya's third principle. So once I've picked a strategy, I'm ready to go, I'm ready to do it. So it's time to get to work. This is the step when I actually carry out my plan. So if I picked the strategy of guess and check, now I'm going to start guessing and checking. And guess what? It might not always work the first time. So if guessing and checking didn't work out for me, oh well, I'm going to go back to step 2, make a different plan, pick a different strategy, and try again. And you know what? It might not work again. And so I'm just going to teach my students to shake it off, go back to step 2, modify the plan, pick a different strategy. Maybe we're going to draw a picture now and we're going to try it again. And this is really where we want to build our students' resiliency and persistence. We want our students to be resilient problem solvers because this is the way math is done even by professionals. And we really want our students to know that. Mathematicians almost never get it right the first time. And in fact, research shows that the more mistakes you make, the better you start to understand something as you iterate through again and again. And the more connections your brain makes and the more patterns you start to see. Okay, so once we've executed a plan that got us to our solution, right, we can move into Polya's fourth principle, which is, I see my rainbow, my energetic rainbows, right? That R is standing for what? It's standing for it's time to reflect. And again, you'll notice I've put another star here because this is another one of Polya's principles that is incredibly critical. That first principle of understanding and this last principle of reflection are the heart of his problem-solving principles. And this is where all the magic happens. So reflection is absolutely critical. And how can we get our students to do it, right? We want to encourage them to analyze their thinking. This is where we come together as a whole group, or when we turn and talk, or when we work with a partner and share what we did and what worked and what didn't work, where we pull out all those beautiful bits of understanding that help us to become better, stronger problem solvers. And so some questions we can ask ourselves when we're reflecting and analyzing our thinking. What was the key factor that allowed me to devise an effective plan to solve the problem? How did I recognize that this particular problem would be best suited by the strategy of drawing a picture? Can I think of a simpler, more effective, or more powerful strategy for solving this problem? So maybe I've gone through and I've solved the problem and I drew a picture and I got the solution. But I took a step back, or I turned and talked to a partner, or I shared out with my class, and somebody else told me that they actually used algebra to solve the problem. That's pretty powerful, right? Because drawing a picture might have worked, but mathematicians are all about being efficient problem solvers. And so if algebra is going to get me there faster, that might be a better strategy for me. But I'm not going to realize that unless I take the time to reflect on it. And for what other problems would this plan of attack be effective? This is an important question because this is where we really take the time to think about which strategies match which contexts. And that goes back to being those persistent, thoughtful, resilient problem solvers, because we might have had to iterate through a few strategies before we got there. And so I'm going to start to notice patterns of which strategies worked best for which types of problems, and that is a skill that is going to carry me through problem solving my whole life. And so there you have it, friends. Polya's 4 problem-solving principles. Understand, plan, execute, and reflect. And of course, I think even Polya would be proud of our mnemonic device, Unicorns Paint Energetic Rainbows, to help us to remember.